Good morning, good afternoon, everyone. Thank you for joining us for this virtual event presenting Switzerland as a keystone actor in the future of sustainable space, but also looking in particular at how do we make space sustainable. And so we start our first session. With Mr. Niklas Hedman, Chief Committee Policy and Legal Affairs Section Office for Outer Space Affairs at the United Nations. And we also have with us for our first opening session, Mr. Nikolai Khlystov, who's the lead for space at the World Economic Forum. So we will be discussing in our first panel what is happening in terms of intergovernmental as well as stakeholders discussions and efforts in order to keep sustainable space sustainable. I will start with some figures. As we all know, space is going through a rapid transformation with new actors within the sector, starting from private companies, going along with the governments. And what is happening is that today space is becoming crowded. If we look at the number of spacecraft and satellites that are being launched, there's a number for the future that is increasing exponentially, we could say, but as well, this number of space debris as well as inoperable satellites is increasing. A few figures, if we look at the debris that are larger than 10 centimeters, we have now 15,000 in low Earth orbit. If we look at something between 1 and 10 centimeters, there are more than 200,000. And so if we look below 1 centimeter, we're talking in the hundreds of thousands. So there is some need to regulate and to make sure that space stays safe and stays sustainable. So I will directly address my discussion to Mr. Hedman. Could you please tell us more about the guidelines that were formed with the COPUOS and what is being done to make sure everything is safe, especially with the different risks appearing as we go by?
Yes, thank you, Khaled. Thank you so much for inviting me to this important panel discussion. And Nikolai, great to have you here. We will have a good discussion here now in the next half an hour or so. Yes, before I answer your question, I would like to just also to inform the audience that so I'm serving as the secretary to the Intergovernmental Committee on the Peaceful Uses of Outer Space, currently with 95 states members, and which will increase to 100 after Christmas. And the committee operates with two subcommittees, the Scientific and Technical Subcommittee and Legal Subcommittee, and those three bodies, they meet every year here in Vienna. The current chair of the Scientific and Technical Subcommittee is Ms. Natalia Aschenau of the Ministry of Foreign Affairs of Switzerland. So Switzerland is a stakeholder also in terms of diplomacy and multilateralism at this level. So I wanted to make that point. Now, your question is very good, interesting, and at the same time, it's complex because we're dealing here with diplomacy at the global level. So multilateralism is not always easy, as we know, because this intergovernmental body, which has worked for 60 years, was founded in 1958-59, works under the consensus principle. So all decisions taken by member states, and here we have all the major spacefaring nations. We have countries that are advanced technologically, but not necessarily have major national space programs, and we have a whole range of emerging space nations and developing countries. So it's really a diverse group of states that have to come together. So in a nutshell, the treaties, the 5 UN treaties on outer space, as you know, the Outer Space Treaty, etc., they were formed long way back in the 60s until the 70s. Since then, there has not been possible among states to agree to any more legally binding instruments. So the focus since the late 70s has been to look into what other mechanisms, what other instruments can be achieved. And there we have guidelines, General Assembly resolutions, principles, and the latest achievement of this intergovernmental body, in particular through the Scientific and Technical Subcommittee, was the adoption of the 21 guidelines for the long-term sustainability of outer space activities in 2019. It took 10 years to arrive at those set of guidelines. They are very detailed and they are predominantly of technical nature, provide recommendations to states on how they should implement those guidelines. In a nutshell, it's all about the safety of space operations. So states are really called upon to make an extra effort to minimize the risk of collisions in orbit, to minimize the risk of breakups of satellites, fragmentation of satellites, which would then obviously generate more space debris, and also to really pay attention to any probability of uncontrolled re-entries of satellites re-entering into the atmosphere. So there is a whole mechanism here by which states are really put on the spot to work together, to share information, to share data, to coordinate and cooperate. However, this instrument is non-legally binding, so it is a voluntary mechanism. And as we all understand, there are no enforcement mechanisms in international space law, and obviously not then any enforcement of non-legally binding instruments, obviously. So it all boils down to the will of states to abide by those recommendations. And it's not easy. It all boils down to the responsibility of states to enhance their national legislation frameworks, to work with their constituents under their jurisdiction, etc. It's a mix and it's complex. I stopped there for the time being, but I wanted to give that overview of where we stand today.
Thank you very much. This, I think, brings a lead to the importance of Nikolai, what you do at the World Economic Forum, which is, as long as you know there's nothing that is forcing anybody, that means that stakeholders, whether government and the companies that they're trying to promote and to push forward, abide by these guidances and by these guide rules to keep space safe. So could you please tell us also from your side, where do you see the challenges and how can we move forward on these points?
Thanks so much, Khaled. Obviously, an important agenda we're discussing here, and great to be in this conversation with Niklas, of course. And I mean, it's the role that COPUOS plays is absolutely critical. If we didn't have that, even with some of the shortfalls that Niklas outlined, you know, where we would be. But I think there is a role to play for other actors and for other stakeholders, right? I think this is a little bit about taking responsibility for what you do, for one's actions, in the absence of other mechanisms which perhaps you know, exist on Earth and in other spheres, right? But I think regardless of other mechanisms, right, even if we get to points where we have binding agreements and enforcement mechanisms, you know, we've seen over the last, certainly over the last 10, 20 years that, you know, different stakeholders, corporate as well, are moving towards, you know, a place where they want to do the right thing. It's not just sort of everybody for themselves. Corporate social responsibility concepts are becoming sort of more embedded in how certainly industry behaves. So I think there is an interesting shift just in terms of how actors operate, particularly from the industry side. But so we are the World Economic Forum. We are the international organization for private collaboration, and we are committed to addressing different global challenges. And of course, space sustainability and safety is a critical issue because space provides so many benefits for all of us on Earth today, and it will continue to provide those benefits. And what's important to understand, it will provide even better and more benefits in the future as more systems go online, as we're able to measure even better levels of greenhouse gases from space. We'll be able to differentiate even better what are the human-made emissions, what are naturally occurring emissions, and really improve our environmental understanding. Of course, there are all the benefits that many listeners are aware of linked to connectivity, and that's of course will increase, et cetera, et cetera. But all these benefits are in danger, right? Of course, the issue of debris. You've outlined some of the numbers. I think some of these numbers, could some argue are even higher in some cases. So. And in the absence of legally binding mechanisms, we've been working with some of our partners on addressing this issue sort of from the bottom up with voluntary behavior, but again, engaging and working with responsible and progressive stakeholders who want to do the right thing, who care about the environment, because they realize, first of all, they won't have a business model if the environment is threatened and the orbits are not operational anymore. So they care about it. They want to do the right thing for the most part. And so one example that really is that I think we've been working on the last couple of years is the space sustainability rating, which in fact is a concept which came out of discussions with different stakeholders, different experts from the space world. Essentially, it's a notion of a rating. You get a rating. It's a voluntary rating. It's a carrot approach. So you get better and better ratings the more sustainable you are vis-a-vis your debris mitigation measures and how your mission approaches debris mitigation, right, from different angles, whether it's guideline following, whether it's different orbits you're going into, how quickly you do orbit, how well you share data. And so forth. So we are at the end of that process. That the rating has been a terrific collaboration with the European Space Agency, MIT, Bryce Tech, and University of Austin, University of Texas at Austin, and that's going on to be sort of offered as of next year by the University of Lausanne Space Center. So we hope that actors and operators will pick this up and will use it, and we'll really try to use it as a way to say, look, we're not just competing on price or performance, we're competing also on how responsible and sustainable we are, because everybody else, from investors, from policymakers, are beginning to notice, are beginning to care, are aware of the issue, certainly in the space sector. And so that's one certainly aspect. We've published also recently an industry debris statement signed by 18 different stakeholders, industry stakeholders from across the sort of the value chain, from sort of some of the newer companies, some of the more established companies, really calling for being able to do the utmost to mitigate debris and promoting collaboration within the sector with different stakeholders. So it's really up to us. It's really up to the industry. I think there is, of course, there's a whole discussion to be had, which would be great to continue now. Is how do these relationships with industry and policymakers, how they organized, what can we do to promote better cooperation and better activity in absence of maybe some of these legally binding mechanisms? Where's the responsibility for national actors? How certain governments sort of look at this issue, and how do we sort of progress and become even more perhaps not just responsible, but perhaps more mindful of the orbital environment and the orbital regime, which benefits all of humanity and will hopefully continue to do so in the future.
Mm.
I think it was addressed to you, Niklas, this question, so you could just jump ahead, Dai.
Yeah, no, one point I wanted to make here, and this is why it's so complex, is precisely the absence of a firm, very detailed regulatory system at the international level. So we have the treaties, and yes, we know there is a constant debate whether the Outer Space Treaty, for example, and the following treaties, whether they are enough today, considering the technological advancement, the proliferation of actors in the space arena, etc. Well, the treaties are there and they are legally binding, and it is without doubt a responsibility of all states parties to the Outer Space Treaty that they must authorize and license national activities performed by non-governmental entities. That is the term used in the treaty, which means industry and private sector and non-governmental organizations. So the private sector has to work under the jurisdiction of the state, and it's the responsibility of this state to then legislate in a way that it provides certainty for the actors, the operators of satellites, if you take that as an example, certainty and predictability. It's important that states take this seriously in implementing their rights and obligations under the Outer Space Treaty, which is there. So that is the legal frame. Now, those guidelines that we have seen being developed over years at the global level at COPUOS, the Space Debris Mitigation Guidelines, a technical document from 2007, and then now the long-term sustainability guidelines, whether or not they are voluntary and non-legally binding or not, and they are non-legally binding, they perform a way for states to hopefully better implement their responsibilities under the legal regime of outer space. It all comes down to the willingness of governments to do this right and understand that we all have to drive together in order to promote the safety of space operations. We see legislation coming, particularly more modern national space acts and laws, are really putting, emphasis on safety, on environmental concerns, on space debris mitigation plans, etc. So when a manufacturer of a satellite and an operator is seeking an authorization and license to perform those activities, we see now in more modern acts and laws of states that they take this seriously and really put pressure on those actors so that we minimize, problems and hazards to safety of space operations. What I also wanted to mention here, and this is probably a very interesting point, the private sector, industry and private sector, yes, they operate under the jurisdiction of one state or the other, I mean, that's how it is. They don't have a seat at the table at the intergovernmental level. So decision making in COPUOS is for governments of states members. But there is a growing awareness and a growing, I would say, understanding of our states, members of this committee, that it is important to really increase the dialogue with the private sector. That is done nationally, but there is also an increasing awareness of, well, we need in one way or the other to listen to the private sector. They are not for decisions, they are not going to make the decisions, but we need to listen to them. So this is a constant movement in that direction. I would say that private sector and industry is important in the space field, and their engagement will increase, and governments have to relate to that in one way or the other. So in one way or the other, this is a positive trend, I would say.
I mean, Khaled, I would love to jump in and
yeah,
perhaps
please.
if you allow me build on what Niklas said. I mean, I think it's the challenge I think that we see is that well, there are several things that come out of this, right? As challenges to make this work. One issue is that there is this desire to compete and to innovate. Money is coming in, private money is coming into the sector. And of course, at each level, there is this balance and there's this tension between what you can achieve economically and kind of profits you can make, and this notion of sustainability, right? And we see this sort of resulting in this discussions of, well, what is the capacity? What is the healthy capacity, environmental capacity of our orbits? And I think for the most part, the governments are starting to look at this. I'm not sure we have any of them have had a great answer yet. I think we perhaps yet to see that in the coming years. But I think it's a discussion that's starting to be had, saying, look, we need to be mindful of how much active objects we have in orbit that are providing all these great benefits and economic value and societal benefits, and how, as part of an overall population that includes lots and lots of objects which are debris of different sizes, right, and which endanger the systems and future systems and even human life, right, if you talk about space stations. So there is that tension, and I think when we start talking about having national states be responsible and implement certain regulations and policies vis-a-vis their national private actors or even universities, for example, then the question of level playing fields come up, right? And so saying, well, yeah, I want to be responsible, I want to implement strict measures, but I'm a bit concerned that some of my actors might go abroad, right? And so then it becomes again back to sort of having some international agreements at whichever level to say, look, we need some basic level of safety that we all agree to, whether it's how many years you're gonna deorbit your spacecraft out of orbit, or what's safe operations, whether it's safe distances, right? Again, which we don't have yet in LEO, which we have some agreement at the geostationary orbit, right? Thanks to the ITU stewardship, maybe perhaps, right, and regulatory regime that ITU provides there. And again, by the way, certainly some lessons to be taken from that. But that question of level playing field, I think, is quite important. And I think this is where we see a little bit of tension and difficulty to moving to, right, okay, everybody's telling us that this is what we need to do. We're going to do it. We're going to be responsible. We're going to be quite strict about operations. And that's why I think we're seeing a bit of perhaps slower response than ideally one could have wished for. And again, the other spark, just what makes it more complex, I think, is that just the dynamics of it are very overwhelming, perhaps, right? I mean, the environment you're operating in, the speeds the objects travel, right? The need for high resolution systems and radars to track all this debris. You can't see all of it, right? You see only, with new radars from some of the systems, some of them coming online private, you're going to be able to see smaller debris, right? But again, not all of it. The systems are getting large, right? Large number of satellites in a constellation. How do they talk to each other? How do you optimize that communication to make sure they don't bump into each other? So there really are a lot of technical questions to safe operations, to making sure there are no collisions. And then there are these regulatory questions from the national standpoint, where even though some of the private actors we see are saying we probably need some regulations. This is not sustainable otherwise. To regulators probably really thinking hard now how to design something which is optimal, which ensures competitive in the nature of this or that national regime, I would say. So not an easy challenge to address.
Nikolai, I think there's something that's very important that you mentioned, is that there is a competition, and there's a competition that is on two levels. There's the competition that is on the government's level to achieve and to move forward, and now it's followed by a competition on, let's say, the corporate level. And so how do we make sure to move forward and not repeat the mistakes that we had on Earth in space? And so, Niklas, do you think that, as Nikolai was suggesting, there needs to be more measures in terms of traffic management even? I mean, we're talking about orbit, but what happens when we start racing to the moon? Because we're starting to see already projects, cislunar supply chain going forward. And so how do we make sure that these rules of competitiveness or of competition are respected? And so is there a need for traffic management purely to move forward?
Well, So first, going back to what Nikolai said, I mean, the whole issue of competition and you know, the way from the international standpoint, how to secure that governments are implementing in the right way and that their national legislation is functioning. When the whole drama behind this is obviously the way to how to avoid flags of convenience that we've seen shipping in maritime traffic. So no one wants a situation where there are states that in a way have a more beneficial legislation with lower responsibilities. So this is always there, a big issue, and this is the reason why we take this seriously, or why states take this seriously at the intergovernmental level. Now, on space traffic management, one interesting point here when we're discussing sustainability and the safety of space operations. So those guidelines, they are fairly detailed. I mean, they are really go into the detailed level of recommendations of what states should do. Now, what COPUOS is doing at this stage now, this scientific and technical subcommittee, is that we have a new working group now, and it's now discussing its terms of reference and method of work, and that will take some time. But the idea is then that the working group will work under a 5-year mandate. Whether this is enough or not remains to be seen. But what I believe is important here, and we see this constantly in this dialogue, is that awareness increasing and capacity building is key for all those actors and governments that not necessarily are major spacefaring nations. They probably maybe only launch 1 or 2 satellites or even a few more, but they are nevertheless also responsible for those activities, and they might be held liable in a situation where their satellite have caused damage to another. So that is very important, that we are focusing really on that element of awareness increasing. The increased dialogue with the private sector, indeed. I mean, governments need to work together with their non-governmental entities under their jurisdiction, clearly, and that we have said. What is furthermore important is to have at the international level that I'm representing here, an organized reporting on the implementation, on how are states implementing those guidelines. What measures do they take in their national regulatory system in upholding this? And then probably we also need a structured information exchange, a way of organized information exchange on objects and events. Events is a term that is used, but there we talk about orbital collisions, breakups, uncontrolled re-entries, etc. So there must be some structured information exchange in this regard. Well, if we do this, whatever space traffic management regime there would be in the future, whether there would be an international regime or not, we see immediately then emerging building blocks for STM, for space traffic management. That is something that will come. And whether it's a bottom-up approach or a top-down approach on how to deal with STM, with those building blocks and those fabrics of STM, I mean, it goes in the right direction. You mentioned, Khalid, lunar governance. If we talk about space resources, the exploration, exploitation, utilization of space resources, for instance, which is very engaging a topic right now that we are dealing with, in particular in the legal subcommittee of COPUOS. That is probably a different governance issue. When we discuss this space environment, I mean, we have the space environment, near-Earth environment, where we concentrate on activities in orbit around the Earth. That requires certain measures, and that is what we have been discussing now for many years here on space debris mitigation and the LTS guidelines. But when it comes to lunar activities and other celestial bodies, not only the moon, but also on Mars and other and asteroids, that would require different mechanism and a different set of governance instruments, in my view. It's not that space traffic management can solve it all. Space traffic management is not defined yet at the international level. So there is no definition on what is space traffic management, which also complicates to the whole scenario.
Nikolai, on these points where eventually there is already debris and you're tracking it. So if there needs to be also a cleanup, who should pay for it? Who should be? Is it the governments? Is it the corporates? How do we set things up so that you also put responsibility? Because at the end, having financial responsibility also forces you to make sure you stay clean. Today, if you look at, the oceans and the pollution in the oceans, who's going to pay to clean up? So is there a risk that if we don't take action on these particular points, and if we look at low Earth orbit, we face the same situation?
Yeah, no, there is a major issue, Khaled, and I think the urgency of the conversation needs to be sort of, it needs to be made more, needs to be stressed. I'm not sure we have many years to solve this issue. I mean, there's a good chance that in the next few years we'll have actually another major collision in some of the really debris-filled orbits, and perhaps that will sort of jolt everybody a little bit into action, which will be unfortunate. But unfortunately, as history shows, this is how we've come about to having really sort of international agreements on international aviation. I think on shipping as well to a certain extent. But hopefully that won't come to pass. But I sometimes tend to be a little bit pessimistic in that regard. That's just my personal viewpoint. But yeah, I mean, the actual debris cleanup is going to be a critical part of this, right? And the sooner we get going with that, removing some of these big objects which can collide and produce thousands of smaller pieces, the better, obviously, right? And there are experts who've worked on this, who've tried to identify the most pressing ones that we should be removing first. Of course, a lot of them come from decades past, from some of the earlier activities by some of the few nation states, right? So the question is, how do we sort of all come together and acknowledge that, look, this is a common problem. We all are responsible for it, and if we don't start acting on this now, we will be paying the price. So there is a state perhaps responsibility at some level, at least for some of the pieces. There are a number of startups that are working on the technologies now to remove the debris, but also to perhaps resurface the satellites so they extend their end of life, the life period, refuel them, perhaps service them. There are ideas that have been mentioned to say, well, each actor maybe chips in a little bit before they launch, right? Proportionate to their system size or whatever orbit they're going into, perhaps, right? So that's perhaps interesting debates to be had and discussions. But there needs to be kind of a system where, whether it's some kind of an insurance policy, some kind of a common mechanism that has resources that says, well, okay, if your object failed, you intended to remove it quickly from orbit, you wanted to be a good actor, but systems failed, which is going to happen. There's going to be services going to come and remove it, right? And so we need to have a mechanism that I think pays for that. But we're going to have objects fail more, of course, and we just need to make sure that they don't remain stranded in orbits, right?
Niklas, from your point of view, how should governments deal with the current situation?
Well, I mean, currently, considering the whole international environment, and those are political issues that we are dealing with here. I think the only path possible is what we see happening now, that states are now really engaged in getting this new working group of scientific and technical subcommittee really going forward in substance, and as I outlined, really look into how do states implement the guidelines. The guidelines are it's a good instrument because it really goes into detail and it puts some pressure on states, but since there are no enforcement mechanisms, as we know, it's difficult to to police any activities. Nobody can do that. So I think, realistically speaking, we have to continue working. Governments need to work together, cooperate, coordinate. There must be a more, I would say, active dialogue and cooperation between the various stakeholders. So not only governments sitting talking to each other, but they also have a responsibility to talk to their actors, you know, under their jurisdiction. So private sector industry must be put in this equation. This is, without that, I don't think that it will work in the future, because the private actors today are really increasing, and they will continuously, you know, build up the bulk of future space activities. So they must be brought into this equation in one way or the other.
And you know, to add to that, you know, I think despite perhaps despite the current situation and some of the geopolitical challenges we have on the ground, space has proven in the past that it could be a place for collaboration in also very difficult periods of time. Yeah. Everybody benefits from space. Yeah, there are certain challenges linked to national interest in space as well, which one needs to acknowledge if you're to advance in these discussions. And you know, there will always be national interests, whether in space or on the ground. But space presents a lot of economic, social, societal benefits, but also national sort of pride benefits. And you know, I think nation states are very keen to make sure they have own successful space programs beyond national interests, beyond intelligence systems. And so, but to have those, you need to make sure that space is functioning. There are rules of the road. You know, you sort of have some agreements, even if they're not sort of formally all formal and written out, but you're sort of understanding of, you know, I'm here and you're there, and you know, and we can support each other in case of, by the way, and I think that goes to one of the earlier original treaties, right? I think not everybody signed that one, right? Niklas might correct me, but if you need assistance in space, right, that will become more pressing as more people go to space, to orbit and beyond. And you know, basically having some basic rules, you know, saying I'm going through this orbit, you know, you're coming up, you know, I have this type of mission, you have that type of mission. How do you have those basic conversations? It's absolutely critical. Otherwise, it's just not going to work. I mean, we're not going to be talking about decades into the future. We're not going to have those decades, at least in some orbits, right? So this will be critical. And yeah, I mean, I think again, we need to sort of figure out a creative way to address the national interests, but build on the collaborative places where there is intersection, where each nation is a winner in having a sustainable and safe orbital environment. I think that's the key way forward to advancing. But let's see how hopefully we can be successful in that.
Yeah, I agree. But just quickly, I mean, when we look at the collective mechanism, the instruments we have in the legal regime of outer space, all those guidelines, resolutions, treaties, principles, whatever, the rules are there, and the mechanism is there to implement those rules. But the crux of the matter is here to get states to do it, you know, to really take the responsibility, and this is what we are dealing with, and also what you said, Nikolai. I mean, don't forget we are all in it together. I mean, if you launch and deploy a satellite in orbit, and you create space debris, that debris might actually cause damage to your own assets also. So we are all in it, you know, all operators of spacecrafts in orbit, they are in it together. So it's a kind of in a self-interest to promote and preserve the safety of the space operations in the end.
I mean, thank you very much. We're reaching the end of the time for the panel. Just to conclude, and bringing what you said, Nikolai, and what you said, Niklas, is that there's capacity that is limited, and there's competition in the same time. And so absolutely, as you mentioned, collaborative and engagement between all stakeholders, whether government and private sector, needs to be taken into account. I leave you both if you have any further comments, and then we will close the panel.
Niklas, please.
I mean, I can just say, yes, I agree. And Khaled, what you said there is precisely correct. And I think multilateralism is important here. Diplomacy, use the diplomatic tools that we have and really work together. That's a must. Yep.
Yeah, I mean, that's absolutely spot on. And the only thing I would say is that on top of that is that we really have to be sort of creative in approaches, right? And not necessarily look for the perfect solution. We may have to sometimes accept things which are 80% okay, right? And have most of the actors on board who want to do the right thing, and sometimes that pulls the rest of the folks forward, right? Because sometimes if you wait for a perfect, perfect solution, that can take sometimes long, and we may miss the boat, as one says. So yeah, and multilateralism is critical. But yeah, it was a wonderful conversation and a critical topic to continue discussing and communicating.
Well, you're welcome to do it anytime with us. Please feel free, and we're happy to have these conversations and push forward this multilateralism and engagement between all stakeholders. Thank you very much for joining us, and hope to see you soon. Thank you.
Thank you. My pleasure. Thank you.
Thank you.
Bye.
Bye-bye.
So this gives us a great introduction into our following panel, which will look into innovation and look into how research can help and how can we achieve sustainability in space. I am now joined by Mrs. Emmanuelle David, the Executive Manager of the EPLFL, École Polytechnique de Lausanne, the Space Center, and she will dive into directly what we just talked about and how do we deal with making the supply chain in space sustainable, with an overview on space debris.
So yeah, so what I was mentioning is that we have a space debris situation today, which is kind of alarming. You have 36,000 objects that are more than 10 centimeters and more than 1 million objects that are greater than 1 centimeter. And what I wanted to point out is here that you can see on the right hand also what is the impact of a 1 centimeter object, which is on a spacecraft, knowing that you have very high velocity. So in low Earth orbit, an object has the speed of, let's say, 6 to 7 kilometers per second. So you can imagine that at those speeds, any impact can have also some catastrophic consequences, even from small objects, and even more if you are considering collisions between two big objects, creating more debris. And the situation, of course, today is not getting better. On one hand, you have the increase of space traffic, so you have more and more objects, more and more active objects, and then you also have increase of debris also due from collisions or from also so-called anti-satellite tests. That's why at EPFL we also initiated in 2019 an initiative on sustainable space logistics. The idea of this research initiative is to, on one hand, explore the new technologies and the new paradigm shift through space logistics, which means also to offer new services for the space economy and for space transportation, such as in-orbit assembly, in-orbit servicing, constellation deployment of satellites, but also having still this glasses or this view of sustainability in order to ensure a long-term use of outer space, And this goes through concepts such as space debris removal, for example, or reusability, refueling, and so on. So today I will focus not on 3 projects, but 2 projects that are two aspects that are ongoing at EPFL. So one is I'll present the space sustainability rating, and also then I'll present you a few key enabling technologies that are in development at EPFL. So the space sustainability rating, the mission there is to promote sustainable behavior of space actors by issuing a recognized rating. The idea there is really to create an incentive to design missions that are compatible with sustainable operations and to also operate missions considering the potential harm to the orbital environment and on others. It's really a voluntary effort from space actors to apply for the rating and then to be able to communicate around the rating and to show how sustainable they are. So for that, we were selected almost a year ago from a consortium which was initiated by the World Economic Forum with the University of Texas, the MIT Space Enabled Media Lab, the European Space Agency Space Debris Office, and Bryce Technology in order to operate a rating that they have been developing and designing since 2016. This rating offers a definition of what is space sustainability according to the studies that has been performed since 5 years. And it's articulated around 6 modules plus 1 verification module. We can see here, I will take my pointer, laser pointer. The first module here is called detectability, identification, and tracking, which is how you can see your object and you can track the object from Earth. The mission index, which take into consideration the orbit characteristics, in which orbit your mission is, and the size of your object to see how you how is the orbit capacity management and how you impact the environment. Those 2 modules are so-called computational module, meaning they rely on a code that has been developed respectively by MIT and UT Texas and the European Space Agency Space Debris Office. The 4 others modules are based on a questionnaire, and they track how the mission is compatible to standard and regulations, if there is any collision avoidance process that is implemented for the mission, so the capacity of the spacecraft to actively avoid another spacecraft if there is a close conjunction warning, how the space operator is sharing data about the positions of its object, and the compatibility to external service such as on-orbit servicing or space debris removal. And all of these modules are weighted through the data verification to understand how we can verify the information that the operator is providing in the others modules, if it's only an assertion or if there is technical documentation that can be provided, or if the data is open to the public through, for example, some filings to the FCC or the internet, the ITU. Those are examples. The benefits for the space sustainability rating for the space mission is really to actively contribute to mitigate the amount of space debris and to really show that the space operator is committing to avoid this the growth of space debris. Also to obtain a certification without disclosing any sensible mission data, and to really promote sustainability level of the mission, meaning that sustainability in space is a complex topic, and the rating should provide, I would say, easy way to communicate about how sustainable the mission is. In terms of roadmap for the implementation of the rating, so as I mentioned, it has been developed by the initial consortium, and now there is a design that has been handed over to EPFL Space Center eSpace, and we are currently performing some beta testing with some selected space operators, and also developing the platform and creating partnerships. And from early 2022, we'll be able to perform and issue ratings officially of companies. So if you have a mission that you want to be rated, then you can reach out to me. Or if also you want to support this initiative, also we are also open for partnerships. The other aspect I wanted to present from what's going on also at EPFL is some of the research projects and technologies we are developing in order to support the vision of sustainable space logistics. So one hard solution to space debris indeed is space debris removal. And this has been also a bit discussed just before. And one of our success story is the creation of ClearSpace, which got awarded in 2019 a contract by the European Space Agency to remove a Vespa upper stage. And ClearSpace is a spin-off of EPFL Space Center. Now it's a startup here here in Canton de Vaud, in Vaud Canton. And the mission is aiming at, for this first mission by 2025, to perform a close range rendezvous and to capture this payload adapter from the Vega rocket, and then to perform a direct re-entry. Of course, this is a demonstration mission. And in the future, the following missions should be able also to remove several debris per missions. We're also working on key technologies within the labs. So for example, for the ClearSpace mission on the relative navigation, meaning to understand what is the attitude of the debris. So in this case, the Vespa, meaning how is it behaving using the 6 degrees of freedom, and then to transmit this information to the spacecraft, so the spacecraft can then choose the best way to approach and to close around the debris. And this is also performed through a project on the capture system concept validation to really understand what is the best strategy for the robotic arm to close around the debris. We are also working on design for demise, is to ensure that while doing the direct re-entry, all the satellites or spacecraft will demise so that none of the objects reach the Earth and then perform either polluting or can be also dangerous for people there. There are also projects on reconfigurable robots, meaning to have robots that have multi-purposes in order to reduce also the amount of materials you need to send to space. Projects also on accurate ground-based and in-orbit tracking for space debris capture, so to better understand the space debris population and also the behavior of those debris. As I was mentioned, are they rotating? If yes, around which axis and at which speed? And finally, a project also on the incorporation of in-situ resource utilization and additive manufacturing for lunar exploration, meaning what would be the properties of materials that you 3D print using the lunar regolith or lunar dust in order to then build lunar habitat on Earth, on the Moon, sorry, and then not to have to bring more materials to the Moon, and to build then the habitats there. So to conclude, so I showed you that it's really the time to act in terms of space sustainability. I presented you a few initiatives that are led by EPFL, such as the space sustainability rating, but also some of the key enabling technologies that we are developing. And of course, there is a strong need for more academia research. No, sorry, it's not academia research, but academia companies partnership or startups partnerships in order to transfer this technology, and also to ensure that I would say the ecosystem is at the edge of the technologies in order to ensure sustainability. Thank you very much. Thank you.
Emmanuel, before I let you go, if you don't mind, I'll just ask you a few questions.
Yes.
So you mentioned this sustainability rating, which is very important. The information that you will collect will it be open to simply the companies that apply to get the rating, or will it be open to general public or stakeholders?
So if you mean the information concerning the mission itself, this should stay confidential indeed between us and the company which is being rated. And then the rating itself, indeed, it's there to be open to the public, and we will of course encourage also the companies itself to communicate on it. And then of course we plan at the end. So when we get, I would say, a critical amount of ratings, to be able also to perform also research and analysis on what is the state of space sustainability, and to see if there are some common trends around the sector.
Okay, so when you will start putting forward now, you are looking to finalize and the final stage of the development.
Yes.
And so should you see this effort being done by government sponsorships or by corporate sponsorship? How do you see the interaction needed to be led?
So for me, I would say the support should come from both sides. And here I'll tell you why, because we want it to be, I would say, a collaborative effort, and to be also not to be seen as an effort just from industry to rate themselves and then to show their best behavior. So that's why we are encouraging everyone to support the effort. And so we are university so far running it, so that's how we ensure also the neutrality and the impartiality around the rating. On top of that, we're in Switzerland, so we know that we are not one of the big actors in the space arena, so therefore also it ensures also this neutrality aspect. However, it's really independent and something voluntary that company comes to us and then ask for the rating.
Just to conclude before I let you go, is that you mentioned an important point, which is the collaboration between the corporate and the investment side with academia and research. And as you mentioned, EPFL has example like ClearSpace of successful spin-offs that go on to become commercially viable or startups. And so among the projects that you mentioned, are these all in the future, in your view, open to become startups and spin-offs? And how would you see the collaboration on these particular projects that you mentioned?
Yeah, so I really see two types of outcomes. Indeed, one is the creation of a startup or a spin-off if you really see that there is a business case for this one application, or also that there can be also a transfer of technology within a company. And this type of collaboration, indeed, then it either depends on the people that are working on the project and then they want to create a startup, and then they can benefit also from the ecosystem, which we have at EPFL through the Vice Presidency on Innovation, where they have programs, but also at the national level. And if we are talking about technology transfer, there are also some different programs through the InnoSuisse, which is the innovation agency in Switzerland, where you can have private-public partnerships, which is also a very successful scheme. But also we're also open to have, I would say, direct partnerships with a company which is willing to develop a technology based on maybe something that is already built here, and wants also to apply it to one of their products. Because indeed those are sometimes very specific technologies, and they can also benefit existing companies.
Absolutely.
So if there's a company and they have a need, they can also reach out to us.
Absolutely. Thank you very much, Emmanuel, for these insights on not only the situation in terms of space debris. You corrected much of the information I gave in the first part, in the first panel, so thank you very much. But also on the opportunity that space represents, and also that Switzerland's represent in the space sector, and to push forward, whether it's on partnership with the private and public sector. Thank you very much.
Thank you.
So now we will move on to our second presentation by Professor Bénédicte Soja, who's the Professor of Space Geodesy at ETH Zurich. Dr. Benedict, please go ahead.
Okay, yes, I hope you can hear me. Okay, great. Yeah. Okay, thanks very much for the invitation to speak here in the seminar. Let me start by sharing my slides. Okay, yeah, I hope you can see my presentation. Yeah, so thanks very much again for the introduction. It's my pleasure to speak here and tell you a little bit about the research we have been doing at the Institute of Geodesy and Photogrammetry and some of the collaborations we have been involved with respect to the space sector in Switzerland. Now, the Institute of Geodesy and Photogrammetry has a long history in space-related research. It started with the establishment of the chair of mathematical and physical geodesy, where already in the 70s, Professor Hans-Gerd Kahle really innovated in terms of satellite observations of the Earth, especially in terms of gravity fields. And yeah, since the early 2000s, Professor Markus Rothacher has been continuing this tradition, especially focusing on a combination of different space-related techniques for Earth observation and also especially for small sat missions. And now in my case, my chair, the chair of space geodesy, was just recently established in April 2020. And yeah, I will let you know more about that in the following minutes. First of all, space geodesy. To give you a short summary and introduction on this topic, it's about measuring the Earth system and its changes. So several parameters, including the geometry of the Earth, how is it changing, like plate motions, crust deformations, and so on. Then how the Earth is oriented in space, like how is it rotating, are there variations in the length of day, and also Earth's gravity field. For example, are there any changes in the gravity field due to the ice loss related to climate change and sea level rise? And therefore, measuring these properties has quite a lot of different applications. For example, you could think of the climate change monitoring, sea level rise. You also need information on the Earth's orientation in space for positioning and navigation. In general, also satellite operations. And last but not least, also spacecraft operations, where you have to know precisely how the Earth is oriented and located if you want to do some pinpoint landing on planets like Mars. Now, at the Institute of Geodesy and Photogrammetry, there have been in the past lots of different initiatives to use space-based measurements. For example, in the beginning, it was interesting to do astrogeodetic measurements, like determining local gravity anomalies. But later, it became much more important to use satellites. For example, global navigation satellite systems to determine positions on the Earth, or also gravity satellite missions to determine global gravity changes. And yeah, that also allows us then to use these satellite techniques to not only observe, for example, properties of the solid Earth, but also of the fluid envelope of the Earth, including the oceans and the atmosphere. Yeah, in recent years in particular, it has become much more important to use also small satellites for Earth observation. And recently, there have been some missions that also incorporate some geodetic measurement techniques, for example, GNSS, Global Navigation Satellite System receivers. And At my institute, we have also looked into using the technique of very long baseline interferometry, which is based on radio telescopes to measure extragalactic objects. And first of all, determine some properties of these objects, for example, like black holes and quasars. And then in the second step, use this these measurements to these objects to also determine properties of the Earth. Like, for example, where these telescopes are precisely located. That means with an accuracy of a few millimeters, or maybe around 1 or 2 centimeters. Now, in this talk, I want to particularly highlight the importance of collaborations between a research institution like ETH and together with the space sector in the industry. And we at the university rely heavily on such collaborations because it is prohibitively expensive to launch our own space-based projects. But we have the capability and the research interest to collaborate and contribute to such missions to improve, for example, our understanding of the Earth, the environment, and also space-related projects. Now, here I want to, in particular, highlight a collaboration that we have with several companies of the space sector and also some research institutions that is related to providing GNSS receivers for nanosatellites. And yeah, this particular project is being supported at ETH by several people, most importantly Gregor Möller, who has prepared some of the slides here. And of course, it was initiated by Professor Markus Rothacher, who has been driving this development over the last decade, I would say. Now, the overall goal is to provide low cost and low power GNSS receiver that is based on commercial off-the-shelf components, and thus producing a payload that can be included in small satellites with very little modifications. So such a payload would weigh just around 100 grams, would only consume around 100 milliwatts, and it's very cheap, so just 300 euros. And this would allow you to give or to compute an orbit accuracy of about 3 to 5 meters. Excuse me. And in this regard, we have already good collaboration with the company Astrocast, who are launching in the coming years a constellation of small satellites in order to provide better communication, and especially for Internet of Things applications. Now, there are already some satellites in orbit that are using early version of our GNSS payload. There have been some prototype satellites that have been launched in 2018. Then this year, there have been 5 additional satellites, which are now part of the constellation. 5 satellites corresponding to the first plane, and then later in June, 5 more satellites corresponding to the second orbital plane. These satellites are using single frequency GNSS receivers, and later in the talk I will introduce more recent developments that will also include dual frequency receivers. But let me go back to the primary motivation why actually this information on precise LEO orbits is useful. First of all, it can be used for Earth observation, which is interesting for science. So, for example, for our research group, we are interested in determining the gravity field and looking into measuring the Earth's atmosphere more precisely. So additional measurements are always useful. However, for the satellite operators, such precise orbits are also very beneficial. First of all, collision avoidance, and this fits very well now to the talk by Emmanuel, because we've seen that there are increasingly more objects in the near-Earth space, and collision avoidance becomes much more important. Also, maneuvers can be then executed in a more precise manner and can save a bit of energy. Now, for the orbit determination, GNSS is the key technology. It can provide orbits up to a few centimeters accuracy if you're using high quality GNSS equipment. The goal is now to also achieve a similar performance with very cheap GNSS receivers, like commercial off-the-shelf equipment. And there we have taken quite a few steps to reach such a goal. Yeah. So first of all, let's start with a performance of the current GNSS payload that is on board of the first few Astrocast satellites. So here's an overview over the orbits of these existing satellites. All of them are at an orbital height of about 550 kilometers in sun-synchronous orbits. And you can clearly see the different planes, which are following different tracks here. And each plane has about 5 satellites. Here in blue, these are the prototype satellites. So these are just 2, which are on a similar plane than these satellites in red here. Yes, first of all, blue ones launched in 2018, red launched in early 2021, and finally the yellow orbit plane from the launch in June 2021. All of these have been brought into orbit using SpaceX rockets. Now, here's some first performance evaluation of this initial GNSS payload board. Keep in mind that these are the single frequency GNSS receivers. Here we achieve an accuracy of about very few meters. For example, in the radial of up to 5 meters, and a long track and cross track about 2 meters when we fit reduced dynamic orbit. And we can already see some anomalies. For example, there happens occasionally reorientation of the satellites so that they point in the direction of the Earth or in the nadir direction. And also maneuvers occur occasionally, which you can see here. Now, the performance evaluation is also very important to, for example, monitor the temperature of these GNSS receivers. And you can see very strong variations within a single orbit because, of course, some orientations are, or some parts of the orbit are a bit more exposed to the sun than others. And you can see these variations also then affecting the clock performance of the satellite. You can see much stronger clock drifts in the times when there's a high temperature on the satellite board. And another test is also to see if the carrier to noise ratio, so the signal strength basically is affected by certain phenomena. And here we are tracking this signal to or the carrier to noise ratio over a few hours, and at some point you can see that there's a dropout, and in this case we have identified that this is related to an interference with other modules on the small cube satellite that are needed for the orientation of the satellite. And yeah, this is something we have to keep in mind, that on such a small cube satellite, yeah, interferences can happen, and we need to be careful monitoring them, since this can lead to a dropout in the GNSS performance. Now, I was mentioning new developments in this regard. We want to achieve even better orbit accuracy, and for that it's essential to use dual frequency GNSS receivers, because those can be used to correct for some residual errors related to the ionized part of the atmosphere, the ionosphere. So we have collaborated with the company uBlocks here to provide their SED F9P receivers, which are low-cost, multi-frequency and multi-GNSS receivers, in a way that we can incorporate it on our payload. It's very small, just a few centimeters and height of 2 millimeters, and with very little power consumption. The problem is that if you buy these commercially, they won't be able to track satellites because of the very large velocities involved there, since these receivers are protected for such applications, because otherwise you could also use them to launch military rockets and so on. So in an agreement with uBlocks for this particular use case of orbit prediction, we were able to remove this velocity constraint to allow the performance of these receivers in space. Yeah, and the design of this payload is already complete and shown on the right-hand side. We will have 4 of these uBlocks receivers incorporated for redundancy purposes. Another aspect is the antenna that is on the small satellites. Of course, they cannot be very high quality due to size constraints. You can see that we have performed some test measurements with antennas here on ground, just to see how well they perform in general. And yeah, you can see that these antennas in principle can reach a level of a few centimeters. Now, an important aspect that we learned from the prototype Astrocast satellite is that the antennas can degrade over time due to all the solar radiation that is hitting the satellite. And so the idea was to protect these antennas with different coatings. And we have tested several materials. First of all, how well they perform in terms of protecting the antennas, but also very important, how they affect the signal to noise ratio on these measurements. So we noticed, for example, that some materials are causing a problem because they reduce the signal strength significantly. Yeah, one test we did in collaboration with EPFL was that we did some orbit simulations using this Aspirant GS8000 signal generator. Here we could simulate the GNSS measurements that we get on an orbit, like very close to what the final CubeSat orbit would be, like for example 550 kilometers altitude. And yeah, this helps also to quantify the expected height error of concerning the GNSS performance. Another important metric is also the tracking performance. So when are observations available and when do we actually get observations? And on the right-hand side here, you can see that the green is when we are able to track the satellite, and we are very close to what is actually simulated. So for almost all occasions, the receivers are able to track the GNSS signals. Yes, here some tests we did in collaboration with RUAG Space here in Zurich. It's also important to test these modules in terms of their performance in vacuum, like what is in space, and also to extreme temperatures. RUAG has these specific chambers where these pressure and temperature conditions can be reached. Here are some plots from that where you can see the pressure initializing and then decreasing it to levels that are close to what is expected at the orbit of these satellites. Then also temperature variations are tested in just a few hour windows, and also the performance of the receiver will then be monitored. And in general, these tests were positive. For example, here you can see the variations of the clock. As expected, there are some variations on the receiver, but this is in a range that is still sufficient so that we can do proper GNSS positioning. Yes. Another test was conducted in collaboration with the Paul Scherrer Institute. As you might know, there's a lot of radiation if you're at a high orbit, and therefore it's important to do also some radiation tests. And the PSI, Paul Scherrer Institute, has a proton irradiation facility where they can test electronic equipment with the radiation levels that are typical in space. And here we tested two cases. First of all, long-term effect by a small amount of radiation over long times, and also very strong doses of radiation in just single events, so-called SEE. And you can see then the performance of the receivers in this plot here. Like after, for example, such a single event, there's a very short loss of the satellite fix, and in general, it works for most periods quite nicely. So this brings me already to the end of the presentation. First of all, I want to highlight that for us as a research institution, it's very important to collaborate with Swiss industry and research institutions in space. And in our case, we have thus successfully developed such a low-cost GNSS module for small satellites. This is currently being improved by incorporating better GNSS equipment, where we have performed multiple tests on the GNSS receivers and also on the GNSS payload board. Still some work needs to be done, and our goal is that we can provide such a GNSS payload board which should behave like plug and play to be used for upcoming CubeSat missions, potentially starting in 2023. This would allow for a much better precise orbit determination of such CubeSat missions, and then increasing the performance of the maneuvers, and also reducing the risk of future collisions. And with that, I would like to thank you very much for your attention.
Dr. Soja, thank you very much for this presentation, which showed us exactly the process and how at each level collaborations and partnership, whether with fellow universities or with the private sector enabled you to go through and have a successful first mission. I think it's a very good example of how space needs to work. Before I let you go, I have a few questions. So GNSS has become really a key component of any space mission, and so the board that you've developed is really lighter in weight, but also less costly. And if I'm not mistaken, it was one of the first time that you had 4 modules to be adapted on. Could you just tell us more about these points?
Yes, very good point. I mean, traditionally in the past there have been very expensive GNSS receivers being used on the satellites, since back then there was not any alternative. But nowadays, with these low-cost GNSS receivers that are so powerful, it becomes much more efficient to incorporate them also on very small and cheap cube satellites. So the idea is then also that you are able to not only include one such a receiver, but multiple receivers for very little extra expenses, and this greatly improves the reliability and robustness of your positioning solution. So we have experienced that on our prototype satellites that there can be some outages due to problems with interferences and space weather events. So having a backup is extremely important to ensure such a reliability in the orbit determination.
And so one further question is concerning the timing. I mean the timing of the information. How do you see this developing and getting better in the future?
Mm-hmm.
The accuracy of the
yes.
timing, I would say.
Mm-hmm. Yes, very good point, because it's not only about like positioning, but also the timing, which is a great asset that is provided by GNSS. And I would say the timing performance scales very similarly to the positioning performance. So when we now move from single frequency receivers, where we have an accuracy of about a few meters, to dual frequency receivers, where we get an accuracy of about a few centimeters, or maybe 10 or 20 centimeters, then we in the essence get an order of magnitude improvement. And that would also be the same for the timing information. So this would allow even better time synchronization in the constellation of the satellites, and also for these communication applications.
Dr. Benedict, thank you so much for your participation and for this presentation that gave us another aspect of how to keep space sustainable with everything that is related to what you did around the GNSS. So with this, we come to a conclusion to our virtual event, Switzerland, a keynote actor in the future of sustainable space. We tried to give you a broad view, first of all, on an intergovernmental level and seeing what's happening and what Switzerland is doing, but also in terms of research and collaboration and partnership between both universities as well as corporates and other stakeholders. It seems clear as a conclusion that it takes all stakeholders to be committed and to be continuously engaged in keeping space sustainable and not transferring the mistakes we've done on Earth in space. With this, our virtual event comes to a conclusion. I'd also like to thank Elena Riquelme, who set up everything and organized things very well from our team at SpaceQuest Ventures. And I wish you all a pleasant day. Thank you very much.